Hi, everybody. Welcome to Data Analytics. We had started some work yesterday. I think some of it was finished, some of it wasn't finished. So let me show you where I am this morning. We're going to continue from there. All right, take a deep breath wherever you are, in and out. Yes. Now I'm going to switch between my iPad and my laptop. You guys already know. Okay, you guys already know I'm going to be switching back and forth. And let me go into the notes from last night. So this is one of the assignment I gave you, the standard deviation story, where I actually had you read this story and answer these questions. What is standard deviation? What important? How important is the standard deviation? What key factors the standard deviation gives you? How important is it? Why do we calculate the standard deviation of a data set? Everybody read this story, had the chance to look into it, and then answered the questions in the Google Classroom. So I'm going to give you the opportunity to kind of take a minute, right, and share it with the person next to you or even your partners. What was your answer? Especially why do we calculate the standard deviation of a data set? I really want you guys to discuss it with each other, especially in this story, how important was the standard deviation. So you guys are going to pause this video right now and just answer those two questions. How important was the standard deviation in this specific story? And why do you think we calculate standard deviation? You pause it and we come back. So in this story, had a manager, right? A manager that was making weekly orders. And the first one was making weekly orders and got an average of 32.3. And then the second manager was making weekly orders with an average of 32.8. Now, some of them, they were doing this because they were trying to predict how many boxes they will need, the week after. So if they only looked at the average, they'll say, okay, on average during the week, we are selling 32 boxes. This is what we should, this is how many orders we should stick to, 32 or 33. But now, when you look at the standard deviation for the weekly orders, here you get a standard deviation of 2, which is a small standard deviation. If it's small, it means that the data is not spread out. It means that the data is centered around the mean. But now this one, it's huge. So it means that your data over here is extremely volatile, all right? Extremely volatile. So what does that mean? If I have a standard deviation that is small, it tells me that each data point in the sample sits an average distance of 2 data points from the mean, or 2 statistical data points from the mean. If I have a standard deviation of 18.9, it tells me that each data point, it sits on average a distance of what, almost 19 data points from the mean. So it means that this data from the second manager is extremely volatile. And it also means that this average cannot be used to predict the next order or the order for next week. That's what it tells you. So the standard deviation gives you a sense of how dispersed the data is in your sample. It tells you how spread out or not spread out the sample is. Now, if it's huge, like that 19, it tells me that I have volatility, right, in my data set. It means that data set here, I cannot use it to do any sort of prediction in the weeks to come. Now, when I have a standard deviation of 2, it means that the first manager's weekly orders are remarkably consistent. And because it's consistent, I can say, okay, next week I might just need to order 32 boxes, right? Or I might just need to order 33 boxes and I should be fine. But manager 2 doesn't have that luxury because that standard deviation is huge. And because that standard deviation is used, it's telling me that I need to go back and collect some more data. So the standard deviation will affirm or will help you determine whether or not your mean is a good measure of central tendency. For example, in this data, the standard deviation, by calculating the standard deviation, you were able to figure out, okay, the data I have is volatile, so I cannot base my prediction on this mean. Now, if I was manager 2 and I did not look at the standard deviation, and I just went ahead and ordered 33 boxes the next week, I'll be in deep trouble. By looking at the standard deviation, I figured out that my data was volatile or pretty much spread out. Henceforth, my prediction for next week is not good, or basing my prediction of how many boxes I'm going to need next week is not going to be good at all. That's how important your standard deviation is. Your standard deviation will allow you to figure out how accurate your mean is at measuring the center of your data. So it's important that you calculate your standard deviation. I hope I helped you. Yeah. So this was the standard deviation story. Take a deep breath where you are. Ask your neighbor, did you understand what just happened? Ask the person behind you, did you get it? If they didn't get it, repeat it to each other. Take a minute and repeat it. What did I just say? Why do I calculate standard deviation? How important is it? How important was it in this story? Y'all talk about it and let's come back. Okay, let's come back. So this is the example we are looking at. I'm going to switch screen now. We're going to go back into R, okay? I'm going to switch screen and we're going to go into R and continue to work here in R. Okie dokie. All right. And these notes are in your Google Classroom. I believe it's under lecture notes for Thursday. This is it. Okay. So now let's look at another example. This example here. So you are given a corporation hired 10 graduates, right? The starting salaries for each graduate are shown. Find the mean range standard deviation of the standard salary. As we find those things, we are also going to talk about them. What does it mean to us? So they gave you the salaries of 10 graduates for a corporation, yes? So there we go. Now remember, we always call the library stats because that's where we're pulling out our functions. I'm going to call that library, we're using library stats, and then I'm going to call the data salary and I'm placing it into a vector. And then we're just going to find the mean here, the standard deviation here, the range, and I'm sorting the data. I'm going to also find the 5-number summary. Okay, so copy this guy and place it into your R Studio and press enter. Okay, so now let's see what just happened here. So when you look at it, it gave us the mean to be 41,500. So the mean salary of the graduate at that corporation is 41,500. The standard deviation is 3135. So every data point lies about 3135.815 statistical data point from the mean. The range, now remember your range, for you to find the range honestly, right? Your range is supposed to be the max minus the minimum. So the range here just gives, so R, here's what R gives you. R gives you 37,000 and 47,000. So literally your range is literally the subtraction of those two. So your range is pretty much equal to, I think I could do something like this, where I write down 47,000 minus 37,000. Yes, that will be my range. The range of my data. Okay, let's type in range. So your range is 10,000. Okay. So your range is 10,000. Okay, now when you sort salary, it gives you your salary from in ascending order, from the smallest to the largest. Another thing that I did was to just get the 5-number summary, right? Your 5-number summary, remember what the 5-number summary is. The 5-number summary will get you minimum Q1, all right? That's your 25th percentile, your median, which is your 50th percentile, your 75th percentile or Q3, and then your maximum. That's what the 5-number summary is going to give you. That's what the 5-number summary will give you. It will give you minimum Q1, etc. So let's just plug that in here and let's see what it gives us back. Okay, so there goes minimum, da 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 da. I could have also got in the box plot. So you'll go ahead and type up box plot over here, and let's box plot that salary to kind of see the shape. Yes, so this is our box plot for salary. Okay, it is box plot for salary. I can insert it here as well if I want to. I can insert my box plot right there. So let me enter from my computer the box plot. Okay, right here. There goes the box plot. Here we go. Now, when you plot the density, I just wanted to know if the shape of my distribution, how is the shape of the distribution? Is it symmetric? When you look at the box plot, it's not bad. It looks as though it's pretty symmetric. Not quite bell-shaped, but kind of sort of bell-shaped. So now, interpretation. What does the mean means? What does the salary, the maximum means? What does the Q1 median, Q3 means? What does the standard deviation mean, right? What is the range? Okay, so I'll need you guys to, you're gonna have in the next, I'm gonna say about 10, 15 minutes, y'all will stop and y'all will write it up. According to the numbers that you have, what does it mean? In the context that we have right here, we're talking about what? We're talking about the corporation having 10 graduates. The starting salary for each graduate are shown. Find the mean, the range, the standard deviation of the starting salaries. What does that mean to me? So I'm going to help you out, and I'm going to pick just one thing to talk about. So the mean over here is $37,000. So it means that the minimum starting salary for graduates at this corporation, right, is $37,000. That's what it means, okay? Remember, you always interpret your results. You can do all the calculation, but you got to interpret the results. Now, the next thing you're going to talk about, let's talk about maybe Q1, which is my 25th percentile. It means that 25% or less graduates, 25% or less starting salary of the graduates at this said company, 25% or less starting salaries of the graduates at this said companies are, what is it? Is it $39,000 or less? $39,000 or less. Does my English make sense? What I'm trying to say is the starting salaries of the graduate of this same company are 25% or less of starting salary of the graduate at the same company are $39,000 or less. I think it makes sense. Because remember, 25% or under. So the starting salaries of this company, right, for graduates, 25% or less are going to be 39,000 or less. I think it makes sense. All right, so that's how you interpret your percentile. Or maybe somebody else is better at saying this. Listen to the people next to you. So for the next, let's say 10, 15 minutes, you guys are going to go ahead and interpret your Q2, the median. Interpret as well the what? The Q3, yes. And then interpret as well what? You're going to interpret as well the standard deviation. No, the maximum. And give it a shot. Mean, we already know what mean is. The mean salary of starting graduates at this company is what? Or at this corporation is whatever the mean was, you just copy and paste. Is what? The mean was 41,500. Okay. The standard deviation, this is telling you how spread out the data is. So the standard deviation is telling me what? That every data point here is 35.815 statistical data point from where? From the mean. So that's what the standard deviation tells you. I hope you guys caught that. You have to write it up. So what does the standard deviation tells you? Standard deviation tells you that each data point in this data set are going to be what? 35.815 statistical data point from where? From the mean. What else do you need to talk about? The range. I really want you guys to talk about the range. The range is 10,000. What does that mean? What is the range? What does the range mean to me? All right, pause the video, interpret, type up your sentences, okay? And then let's come back. You type up the sentences, you discuss with the people next to you, check, check, check. And we come back in the next, even about 10 minutes, 10, 15 minutes, and we come back. Okay, so here I want to talk about, this is still the example we talked about, but I really want to look at the range and what does the range tell me, okay? Remember where we were, all right? Remember what your mean was. So imagine, I have that density because I want to talk about what the mean is. Your mean is 41,500, correct? Remember what your data was. Your data is, when you sorted it out, you went from 37,000, 38, 39, etc. So let's plot that here, okay? Let's plot it here. That was our mean. All right, let's do this, okay? That goes our mean. If I add standard deviation, whatever, let's go maybe in increments of 500 no's, or maybe just an increment of, so I'm gonna do this, X bar plus standard deviation, X bar plus 2 standard deviation, X bar plus 3 standard deviation. This is gonna be X bar, which is the sample mean. This one is X bar minus standard deviation, X bar minus 2 standard deviation, X bar, and I'm gonna put here what? Minus 3 standard deviation. Remember what your standard deviation was, 3135.815. So really what I'm doing is, for me to get those numbers, 3135.815, I'm gonna add 41,500 plus 3135.815. 82. Let's do that. So this is going to give me 47. Yes. Just to be on the same page. 41,500 plus 3135.82. So this is going to be here 44,635.82. Okay. 3135.82 times 2. I add 41,500. This is going to give me 47,771.64. So I'm doing something here, okay? I'm trying to see where I fall. 41,500 minus 3135.82. This gives me 38,036.4.18. All right. Now let's do 3135.82, multiply that by 2, subtract it from 41,500. And this gives me about 35,228.36. So let's change pencil. Let's go here. So if I have a salary of 37,000, I'm somewhere here. Do y'all see that? If I have a salary of 38,000, I'm somewhere here. If I have a salary of what? The next thing is 39,000, 41,000, 39,000, I'm here. 41,000, I'm somewhere here. If I have a salary of 42,000, I'm here. If I have a salary of 44,000, I'm somewhere here. If I have a salary of 45,000, I'm somewhere here. And 47, I'm somewhere here. So if I'm a starting graduate at this company, first thing first, if I get a salary of 37,000, I'm way below the mean. Do y'all see that? That means that my pay is very low. If I come in and I have a salary of 47,000, it means my pay is high. What could be the reason for my pay being high? They probably really wanted me. They really wanted to hire me. They really wanted to work with me. So they were willing to pay the big buck. But for somebody that comes in a salary of 37,000, either there is some sort of prejudice, discrimination, or they just didn't have the budget or the money to pay me. And maybe me, myself, I did not ask for the right pay. I did not ask, or maybe I didn't even do my homework by finding out what is the mean salary of the graduates in this corporation. Your homework as you go and find jobs in the near future is to find out what is the mean salary of the people that work here as they start. So if you're starting graduates in this company, what should be your mean salary? Your homework is to find out that it is 41,500. That is your job. And the moment you find that out, then you need to market yourself in such a way that they put you in this interval right here. You don't want to be under the mean. You want to be what? Above the mean. Are we all on the same page? So when we say my range salary, right, is 10,000, it means, okay, you know, I'm ranging 10,000, and notice 37,000, 38,000, the difference is 10,000, etc. You want to make sure that you know what is the range salary, what is the median salary, what is the mean salary, and you want to make sure that you lie above the mean. Your salary should be above the mean. In fact, if your salary was somewhere here, let me highlight that in orange. If it was right here, you will really be above the curve or above the pay. It means that you're quite special. Now, if your salary lies over here, below 2 standard deviations from the mean, you really need to think about the fact, did they really need me? Did they really want me? Are they exploiting me? Why am I staying here? Why should I work here? So it's important to have those sort of numbers. And I'm glad that you guys were able to see what I just did. All right, so see what happened here. You can imagine, this is what I just did, see? This is just what I just did. This is around the 41,500, we best believe it. This is around there. This is around that. That's why I had a density plot to kind of give me an idea of where my mean is. But we calculated it already. But now when we put it in a graphical formation like this, we're able to kind of literally see what the hell is going on, excuse my language. So we want to make sure that we are above the mean salary-wise. All right, pause the video, talk about what just happened. Why did I just graph this curve? What did I just talk about? Why is it important to be above the mean in this specific scenario? Pause and talk about it. All right, coming back. So now let's go to the notes for today, okay? I'm gonna switch screen, all right? I'm gonna be switching screen right now. And let's go in the notes for today. Okie dokie. So the notes for today are right here, okay? We're going to use some real life examples to do a little bit of work. And then there's going to be a lot of interpretation. I'm going to send you guys do a lot of interpretation on your own. It's really just you exercising and you doing, etc. This is a lot of our work. The first thing you need to do, all I'm doing with you right now is to show you how to download this data into your desktop. That's the first thing. If you have it on your flash drive, it's perfect. So if your data is on your flash drive, it's beautiful. If it's not on your flash drive, remember when you go to the Google Drive, I believe, for our class. Let me find the Google Drive for our class, my drive. That's ideation, data analytics. I think it's in day 2. I have these 2 data right here. So these are the data I'm talking about here. So I can literally, I'm going to start with this data. I'm going to download it. It's a sample of your class. I cleaned it up everything. So I'm going to download this on my desktop. I'm going to make sure that it's on the desktop. I'm downloading it just to be clear, just to be sure. So this is the data here. Now, if I go into my finders, if I go to desktop, that data should be there. See, here goes the data right here. It's on my desktop. It has to be on your desktop for this thing to work. It has to be on the desktop. So once I have the data on the desktop, then I can start working. You need the data on the desktop. Okay? So this is where you are. Once you have the data on the desktop, then you can start working. Now you don't need this to start. You only need copy and paste. Place it here. You need this to start. Okay, let's copy and paste that in. There we go. Let me see. Unexpected. Okie dokie. Let's do this. All right. Remove these. And then let's start. Okay. Once you do that, it reads data and it shows you the data up here. Okay. All right. So you're pretty much ready to start. You're pretty much ready to start. Now I'm calling that data dot. make my life a bit easy. See, I call the data dat right here. Call the data dat. Now, if you want to see the names in the data, summary of your data, box plot of a variable here, box plot of H, you plug it here, right here. So it pretty much gives you what? It's going to give you, yes. So I'm going to send you guys do this work, okay, where you put the code in and you make sure you get the same result as me and you look at the interpretation. Right. See, I interpreted it for you, the 5-number summary right here. Go ahead and interpret the max for me. What is the max telling me? And come back. I want you guys to get the same thing as me and you come back. You plug in the code, you interpret, you come back. You plug in the code, you interpret, you come back. You plug in the code, you interpret, and then you come back. Same thing for the categorical frequency crosstabs. Plug in the codes, and then this is what you get. What does that mean to you? For example, here it means that in this classroom, you have about 11 people from the West Province of Cameroon. What does everything mean here to you? This is just exercises. What does this bar plot of age tell me? What does this bar plot of gender tell me? What does it tell me? Can you interpret this in your own terms? What does this frequency tells you about the data? When you look at this, this is just table for a private university. So there are 18 people from UCAC here that want to go to UCAC. So interpretation, and then try to do this on your own. And then let's come back, okay? So this is it today. We're just going to work. You're gonna plug in the codes, look at the outputs, and try to interpret it. Plug in the codes, look at the output, try to interpret it for the next 30-40 minutes. And then I'm gonna come back in and answer any questions you may possibly have. That's it for today. Okay, you're gonna have about 30 minutes to do this. That's it for today. So see you in a little bit. Let me repeat myself. Just make sure that you download this data on your desktop and then what? Plug in codes, look at the output, interpret. Look at the output, interpret. Plug in code, the code is in blue. Look at the output and interpret. The codes are in blue. Look at the output and interpret. And then I'm trying to make you do this on your own and interpret. And then we're gonna come back in. My interpretation could be similar to my friend, like it could be different. It's all good. Come back in. All right. See you in a minute.